Today we're working on the 40s. You're going to do a little rock hopping or island hopping. Remember, those waters are very dangerous and you can only use the bridges to get from one side to the other. All right, so water is a molecule. H2O is made up of two atoms of hydrogen and one atom of oxygen. So if we have one molecule of this, we have two H's and one O. That's what we're saying. In 1 mole of water molecules, there would be 2 moles of hydrogen atoms and 1 mole of oxygen atoms. So this little note down here says subscripts. That's these numbers right here, these numbers that are small, that are lower than letters. Those are called subscripts, and those can be read as mole ratios. So in water, we have 2 moles of hydrogen and 1 mole of oxygen. And those are infinite sig figs. So water is H2O. It's never just HO or H2O2. That's no longer water. So it's always that ratio. In a dozen silver sulfide molecules, there's how many dozen silver atoms? Pause the video, see if you can do these next 3, and then replay the video. A dozen molecules of silver sulfide has a, see there's 2 there? So if I have a dozen of these, I have 2 dozen silvers. If I have 1,000,000 of these, I'm going to have 2 million silver atoms. If I have a mole of these, I'm going to have 2 moles of silver atoms. Again, it says subscripts are mole ratios. So in the silver sulfide that we have here, there's 2 moles of Ag for every 1 mole of S or sulfur. And again, those are infinite sig figs. So here we go. Here's our first problem. We're going to look at it. It says how many atoms of silver are there in 5.29 moles of silver sulfide? Well, our map's a little different than it was before. So if we look at this, we're going to be going from one substance, Ag to S, and we're going to be going to a different substance, which is our silver, our Ag. So that's something that's a little different. That's going from mole island to mole island. So if we look at this problem, it says we start with 5.29 moles of silver sulfide. I'm going to erase this a little bit, lower it a little bit. So whatever label I have right here up on top, I have to put on the bottom of the next step. So it's going to be moles of Ag to S. So we're going from silver sulfide to silver. We have to go across this mole bridge. If you look on the cover of your unit pack, it talks about infinite sig figs when it comes to subscripts. So we'll talk about that as we're moving along. But what we're going to do is we're going to move from the silver sulfide that's up here, and we're going to move down here to silver at the next mole island. Right up here now we have moles of silver, but the question is how many atoms of silver do you have? So we do not want our answer in moles of silver, so whatever label's up there goes at the bottom of the next step. Moles, Ag, and we can go from moles of Ag over here to atoms of Ag. So we can do that, atoms, Ag. Our mole map allows for that. We're now going to put in some numbers. So when we go from mole island to mole island, we use subscripts. There is a 2 right there, meaning that there's 2 Ags for every 1 Ag2S. So there's 2 moles of Ag for every 1 mole of this Ag2S. So right there, that's where that 2 comes from. 4 right there. When we're going over to atom island, 6.02 times 10 to the 23rd comes into play. We always put that with the atom, 6.02 times 10 to the 23rd. Because if we put it right here, that'd be a mole of moles, which would be a very huge number. So 1 is going to go with moles of silver sulfide. All the labels cancel out except for our label of atoms of silver sulfide. So that's going to be our label, atoms, excuse me, not silver sulfide, of silver. And if we crunch the numbers on that, and you should definitely try this on your calculator at home to make sure that you're doing it correctly. With correct sig figs, you get 6.37 times 10 to the 24th. If you don't get that on your calculator, you're doing something wrong, you need to come in for help. Make sure you are getting it to the 24th. If you're getting it to the 23rd or 25th, you're punching it into your calculator wrong. All right, in class, we would tell everyone to go ahead and try this problem a little bit and see how it goes. I would encourage you to do the exact same thing. All right, the question is, how many grams of N, nitrogen, are in 3 moles of nitrogen gas, which is a diatomic element? So nitrogen gas, 78% of the air that we breathe is N2. So we're going to start off with 3.0 moles of N2. You always start with what they give you. A multiplication sign, a division bar. Whatever this label is up on top goes on the bottom of the next step. Moles N2. All of that should be reflex. It just pops right onto the page. You don't put a lot of thought into it. You just follow the pattern. So right now, this is where we are at. And this is for N2. But we want to know how many grams of nitrogen. Well, N2 and N are different substances. So we do, in fact, have to go across this bridge. So we can go from moles of N2 right up here on the top. We can go down to moles of N. We can absolutely do that. And so that's what we'll do, moles of N. Do we want our answer in moles of N? No, we want it in grams of N, or grams of nitrogen. So that means now we're going to go over here to this island. We don't want our answer to be moles of N, so multiplication sign, division bar, whatever label's on top goes on the bottom of the next step, moles of N. Can we go from moles of N right here over to Graham Island? Absolutely. So we can go to grams of N. And now we can pop in some numbers. So when we go from Mole Island to Mole Island, this step right here, we're going Mole Island to Mole Island. We use the subscripts as infinite sig figs. So if we look here, there's a 2 right there. So for every 1 mole of N2, we have 2 moles of N. So this 2 is where that 2 comes from right there. When we are going from Mole Island to Graham Island, we use the molar mass off the periodic table. And this is the molar mass of 1N. So if we look at the periodic table, the molar mass of nitrogen is 14.01 grams, 14.01 grams per 1 mole. All the labels cancel out except for grams of nitrogen. So our label is going to be grams of nitrogen. Pause the video, crunch the numbers, see what you get. If you do everything correct, you get 84.06 grams of nitrogen. But if we look at the sig figs that we have out there, this one at the beginning has 2 sig figs. This has infinite, this has infinite, this has infinite, meaning it has as many as it possibly have. We're not going to look at it. This one has 4. So we need to have a 2-digit answer, so our answer is 84 grams of nitrogen. So for the rest of the class, the students worked and compared to each other. So if you have questions, please come in.